Okay, guys, welcome back. Now we'll see what happened. I'm trying to share, trying to do this exercise from Fastai. It's deep learning neural network. Okay, and I'm using Kaggle. So if you are new to Kaggle, you want to just like go to kaggle.com. Let me see here. Go to kaggle.com, right? And you can just sign up for free. If you have a Google account, it's going to be so much easier, right? Kaggle.com is basically is a crowdsource for competition for data science for a company who wants to outsource their data, right? And they some normally they'll give rewards for the data scientists or deep learners or learning engineers to solve their problem, to make prediction about their let's say their future like sales in their grocery store, to make prediction about what is the image they're looking at, whether there's a breast cancer or not, to make prediction whether there's a dogs and cats in the picture or not, and so on. So just go here and then you can just sign up for free. And then I want to show you that let me see. Okay. And then if you want to learn about deep learning, and you can go to here, Fast AI, fast.ai, right? It has a very great resources, right? And you can just take their lessons, right? Um, but then if you take it from the Fast AI, then you have to like set up your own like graphical graphics processing parallel unit, the GPU, right? Whether you can like run it from AWS or you can run it from let's say Google Cloud and so on. But it's too troublesome because you have to manage a lot of dependencies. You have to manage to set up the GPU to works, and that itself just setting it up, it could take hours, right? Especially if you're not familiar with that. So to make it easy, some one of the students, I think from um, Fast AI, has already uh, kind of ported the the Fast AI um, um, course, especially the part one, this one, into the Kaggle. So and Kaggle basically provides a free GPU for free, right? Within I think it's about 6 hours or four hours time slot. So you can basically and all the Python dependencies and everything is already set up. So it's very like quick and easy and kind of effective and free to use Kaggle. Um, and a combination of FastAI and Kaggle, I think it's like unstoppable. That's I think this is the fastest way for you to learn. Um, I'm trying to find uh, somebody actually posted um, on. Let's see. I couldn't find it. Yeah, somebody posted on Medium about uh, all the links necessary to get you started to run the FastAI um, library inside Kaggle. Right. I just couldn't find it. Let me let me try to. Um, oh well, I don't know where. I will provide you the link once I could find it. Let me see if there's. Nope, it's not here. Oh, I think it's here. Okay. So you go here, you go to medium.com here, this link basically. So he's I think it's a student of Fastai, William Horton, this guy. So he's basically posting this article about how to use Kaggle kernels together with Fastai. So basically you take advantage of the free GPU and all the setting up all the dependency of all the Pythons and all the framework, right? Because it's using also Keras, using I think also part of it is using TensorFlow. So there are so many dependencies that you have to manage if you're not familiar with that, and it takes quite a long time. Okay, so we'll go with lesson one here, right? Just click this one, and then you're gonna go. Um, it's gonna open up your um, window and goes to Kaggle, right? And then you have to set up your account, right? Once you set up your account, you just click the fork. You have to fork it. Forking means you kind of copy this whole thing basically, so you can like run everything on your own. So once you click this fork, you're gonna go here, right? And then the time here is already running like 18 minutes out of 6 hours here, so it will give you like a 6 hour time slot. But if you're on idle, you're not doing anything, I think for like you're not even moving your cursor for like 1 hour, they will like stop it, right? Because like it's wasting energy. Okay, so you can ignore this first, this commit, right? Okay, so we're here right now. So we're trying to basically to do an image classification, right? Using deep learning, and inside deep learning, there's many algorithm. One of the algorithm for image classification is called convolutional neural networks, right? If you already um, know what is convolutional neural network, that's fine. But if you don't, then what is neural network, especially, and especially to find the inspiration why you need to learn all this stuff, right? You can look at my previous video, right? But basically, convolutional neural network is basically a structure or a model um, that are based on the basic understanding of how the human brain works, right? So the neural is comes from I think the word neurons, which is basically we have I think millions of neurons inside our brain, right? And each of those neurons will be basically interconnected to one another, right? So based on that inspiration, we take that and then we apply it to solve problem in the real world. So this type of this is also part of the machine learning. If you are familiar, also what is machine learning, and so if you're still confused, what is machine learning, what is deep learning, what is artificial intelligence? Basically artificial intelligence is trying to understand or trying to basically to ask the question if machine is possible as intelligent as as um, as the human, right? So with inside the artificial intelligence bubble or ball, there is a subset of the discipline or approach which is called machine learning, which is basically uh, um, uh, instead of the traditional way of programming, which is the human has to tell the machine step by step of what to do. In the machine learning approach, is we are just become like a more like a teacher. We are providing data to the machine, and the machine sort of learn on its own. So it kind of program on its own, right? So it's kind of magic if you like hear it for the first time. And inside the machine learning, there is a so inside machine learning, there's many algorithm, right? That's, like Bayes, using Bayes theorem, using random forest, using XGBoost, using support factor machine. And one of the algorithm that are very powerful is called neural network, or is also called deep learning, right? So well, deep learning itself is branches out to like neural network, and then there is also GAN, which is generative artificial network. There is a recurrent neural network. So um, convolutional neural network is just one, a subset of the algorithm inside the deep learning. So I hope to make that clear to you before we start. So if you're still confused, don't worry about it. Just think of it is just like one of the algorithm or method to use. And this method, convolutional neural network, is as a method is a famous method and is very effective to classify, to differentiate an image, right? So it will know whether this image is a hot dog or not a hot dog, is a cat or a dog, or is a what type of cat, for example, a Siamese cat, or a, I don't know, stray cat, or any other type of cat, right? Um, okay, so in this first lesson, first fast AI lesson, we are basically trying to identify whether the image is a duck, is a dog or a cat, right? So we are basically given about 25,000 labeled dog and cat. Label means all of the photos, right? So if you open here, go under here, under the input here, the data. So there's this dog and cat redux, right? And then there's inside this folder is test and train, right? Inside the training, there's all of this .jpeg file. Basically, it's an image file, and all of this image file has already a label, and the label says the first word is just a cat, cat. So if you scroll down, but I cannot show you here because there's, I think there's 25,000, right? There's going to be a label of dog too, right? So it's already labeled, and this image, every of this image is basically a data. Remember, in machine learning, we are acting as a teacher, so we are just giving a data to the machine, right? And the machine will sort of figure it out to write the instruction how to achieve the conclusion that is a dog, that is a cat, that is a dog or a cat, right? So if you look at the structure of the folder is um, train and test, right? So for now, we don't really worry about the tests, right? We'll do that later, but we look at the train first, right? So there's 25,000 here, and among this 25,000, 12,500, so half of it, 50%, is a test set, right? So it's over here. There's 12, half of it is a test set. Um, and on the test set, that's not labeled. If you look at it, it's like 1.jpg, 10.jpg, 100.jpg. So it's not labeled. That's the machine has to predict whether this image 1.jpg is it a cat or a dog, right? If we see it, we will know it because we're human. So and by the way, all of this, like, they call it also the software 2.0 as compared to software 1.0, right? So software 1.0 is basically the traditional way of programming, which is, like I said earlier, you instruct step by step the machine what to do. In software 2.0 is the opposite. You sort of like let the machine figure out on its own the instruction. You just have to fit the data and the label, right? Yeah, whether this image is a cat, this image is a hot dog, image is a person, this image is a bird. So you provide the data plus the label. Um, so what am I forgot what I was going to talk about. Um, I really forgot what I'm gonna talk about. I don't know. Um, okay, I really forgot. Gee, my Grisel, I guess I'm getting older or something. Anyway, all right. Well, let's just go back on this. Okay, so 50% is a test data, right? And according to this, in 2013, which is about 5 years ago, right? 2013, the machine classifier, right, can score about 80% accurate, which means 20% not accurate, right? So if we can beat 80%, then we will be the cutting edge of 2013. Okay, all right. So now we'll just do this. We'll run this code. Okay. So you can click Shift Enter, right? Um, this is just a boilerplate, just to make it ready. So in case if you use it later on, this all of this framework or library, then you can just use it. So, but first you have to like kind of like import it first, right? So there's basically two ways. You can press this play button over here, right? Or you can just shift enter. I like the shift enter. Sorry, shift written, right, on the MacBook there. And then it will tell you whether it's already being executed or not. So the asterisk, it means it's still being executed. If you see a number like this, number two is that means it's already executed, right? So if you execute it again, this number is going to increase, right? So to three, right? So you kind of know what are the sequence here. So this is the first one and you execute it, and then this one number three. So if you do this, you execute this, it's going to be number four, for example. There you go. So over here we just import a bunch of library from Fastai, right? Because you're using Fastai library. Um, so think of it, library is like something that abstract to make it easier for you to program, right? You don't want to program like in a machine code level because it's so difficult, right? So we want to program like in the higher level because it's easier for human to it's more intuitive for human, right? So this FastAI library, all of these things like FastAI.transform, FastAI convolution learner, FastAI model, right? FastAI dataset, SGDR, and the plots, right? All of these are a bunch of library, uh, just to make it like easier because in deep learning there's so many things to tweak or parameters to tweak. So all of this library just to make it easier for human. So instead of tweaking like a million or like I don't know, going through like instead of like a hundred codes or 1,000 codes, you using a library you can just program using like 5 lines of code or even like 10 lines of code, right? It's so much more intuitive, right? So okay, so we did that. We already import a bunch of FastAI library, and then we're gonna determine the path, right? So the path here is, if you look here, the data structure is from the input. So that's why here is like input, right? And then size is 224. This is pixels, right? So if you look at the data image, basically it's just a bunch of pixels, right? From I think 0 to 256. Um, why 256? That's a good question. I don't know. I don't know why 256. I think it's 2 to the power of 8, probably. I don't know. Well, anyway. But uh, basically, if you look at an image, it's basically a bunch of it's a bunch of numbers, right? From 0 to 156. I think 0 is the darkest, and 256 is the lightest, or vice versa. Um, let me double check, right? Image pixel 0 to 256. I think 0 is the darkest. Like the lowest number is the darkest. Um, no. Okay, pixel, image pixel, right? Let's see. Yeah, I think zero is the darkest. Yeah, the darkest pixel, this one. The darkest pixel is fully black, zero. So 256 is the lightest, right? So from black to gray, and then it gradually becomes like really white, very bright. Okay. Um, okay. So okay, we're gonna run the path. Okay. And then to do deep learning or neural network, it needs NVIDIA GPU. NVIDIA is a graphics card to because and GPU stands for graphical graphics processing unit. It's basically it's like a CPU, you know, if you're familiar with Intel, but this is a dedicated CPU to process um, deep learning competition because deep learning competition is basically parallel instead of series. Yeah. So and the framework, the programming framework, is called CUDA. So this is just to make sure whether um, there is that framework is available. So if you run it, it's supposed to be like give you like a true value. Um, and then there's all this one is also to check as special accelerated functions for deep learning in a package called CUDNN, right? Also enable true. Now we're just gonna do like a check the path here, make sure it's correct. Okay, so there is a train and test. If we list the directory inside the path, there is this train and test, right? So basically looking inside the directory, right? And this one is just putting the right file into the right into a variable, right? So like this one, I'm just gonna put it out. So f names, right? And then comma labels. So f name is basically is a bunch of array, right? This one that inside that array basically is a bunch of file for the training, right? So it's basically this file, all of this file, and they put it inside an array, right? This one, cat1, cat2 until like a doc1 until doc 1999, right? So there's remember that we have like 25,000 of this image, right? And the f name, sorry, the label is basically is array, is another array, but instead of the file image itself, the label consists of the the output of that particular file. So for example, if the first file here is a cat, then it will give you a label 0, right? So cat basically 0 and then dog is 1, right? So so you can see it from here. So it's like np.array if 0 if cat in fname else 1, right? And then this is just going to show you the image, the sample image of the first, this one, the cat 0, right? Basically. So if you want to change it to f, let's say 1, which is the cat 1, this one, right? and so on. So again, you can put, let's say, the last one, 25,000, should be a dog, right? Oh, it's out of bound. I think, oh, because it starts with zero, all right? So it has to be 2424999, right? That's going to be the last image. There you go. It's a dog, right? So if you do, let's say, -1, I think it's going to be saying out of bound because there is no such thing as it starts with zero. Oh, okay. So if -1, it starts going back again. Okay, cool. So if you do -2, it's basically the same as 24998. Got it. Oh, what did I do? Yeah. Okay. Okay. So if you put minus, it will go back. But if you put more than 25 to 24,900, it doesn't want to go. It doesn't want to go cycle. Okay. Got it. So this is how I learned too, guys. So I just like play around. What does the code do? You know, sometimes it's like the first time I see that um, programming language, and if I'm not sure what does it do, so I just like put it out. I want to know what does it do actually, the code, right? Like plt.im show image basically it's showing the image, right? But you can also want to know what is image. Image basically it's let's find out. Okay, what is image? Okay, so image basically is a bunch of um, so remember pixel is basically a bunch of numbers. So the image itself basically is a container or is a matrix is a container of that value of that particular image. So when this image basically is printing, let's do the page one zero first. It's basically all of the value of that particular image, right? In in numbers, in pixels. So this is what basically the machine see or our computer see. Our computer doesn't see an image. It's only our eye can see an image. The computer itself see all just sees just a bunch of zero and one, right? Binary. And and zero and one, if you go to a higher level, a little bit up, not to the highest level. The highest level will be an image which we can see, right? It's a bunch of numbers, right? And this number is basically from 0 to 5 to 56, right? And then we have 0 as the darkest the darkest one, so it's completely black, and then 255 is um, the um, the lightest one. How do you get to 256 255? I think it's 2 to the power of it. That's it, 2 power of 8. Yeah, it's 256. Yeah, 2 to the power of it. Yeah. Because basically it's a binary. That's how the machine, the computer understand the language is 0 or 1, and 8 is basically the number of bits. So it's 2 to the power of it. So you have 256 uh, like bandwidth or options, so to speak, to choose from. Okay. So here's that, and then you can see also the shape of the image. Let's see what does it do. So basically, it will give you an output of the number of pixels on the what's this? The row, which is 374 pixels, and the number of pixels um, on the column. No, sorry, on the row, on the horizontal axis. And 3 is basically the number of channel because this is a color channel, so it has red, green, and blue, right? So, but if you have, for example, just black and white, a gray scale, they call it a grayscale image, it has only one channel. So this is going to be just, I think, just one, right? Okay, and it's just looking of the image inside the image like this, but it's just constraining like up to how many number of pixel you want to look, right? So this one is just you want to look at like only four. I think the first one to four, um, what do you call that? Rows, right? And then you just want to also look to look like one to four, the first, um, how do you say it? I'm so tired. I have to drink first. um, the first, I think, matrices. So if I change this one to five, for example, like that, it will become like five columns. Oh, sorry, five rows, right? But it's still having a four kind of matrix, I think, matrices. Yeah. So anyway, this is just looking the inside of the image, right? This function. Um, okay, so now we're building the model. So once we kind of like put all the because we need to train, right? We need to remember machine learning software or software 2.0. We feed in the data and the label to the computer, and the computer will figure out on its own how what sort of like or learn on its own or like write, so to speak, write the steps required instead of us. We are the one who's writing the steps. The machine will do it on its own. This is what it's called by actually learning. That's why they call it machine learning, right? So um, before before we even like input all of the training data and also the label, right? We need to first we need to pre-process all of the necessary, like which one is the training data and which one is the label, right? So this basically what we did. Basically, just make it ready, right? Make put all of the necessary like um, uh, training data in the right variable and put all the necessary label in the right in a variable. So yeah, so we'll be ready to put it into the model, right? So now the data is ready to be like put into the model. But now we have to build the model, right? So what is a model? A model, remember, so um, it's so when we put the data, right, into the machine or into the deep neural network, right? And this deep learning network has a model, has an architecture, right? And there's different kind of architecture, like regular neural network architecture. There's a neural network architecture, and inside of that, each of this architecture, like we're talking about convolution neural network. Inside of that architecture, there is also you can like tweak the models more uh, how to say it, more tuned to the training data that you're gonna put in or insert inside that model. So you have to tune s- um, or you can yeah, you can tune the parameters basically. So and over here, instead of we're starting from scratch, right? Starting from the beginning, totally like completely like um, training a new model from scratch. We are actually using a pre-trained model. So the pre-trained model here, and by the way, this method, this using a pre-trained model is called transfer learning, right? So if you heard from other like tutorial, whatever, what is transfer learning? Transfer learning basically the idea that you're using a pre-existing model that already being trained and successful, right? And use uh, s- uh, that model, and you just take out the last layer normally, right? And then insert like a new, like the last layer, the predictions, but you keep the remaining layers, right? And that's called basically a transfer learning. The idea basically is because competition is expensive, especially now still. I think it's still getting cheaper and cheaper. And not everybody has a graphical processing unit. Like me, I don't have one, right? So that's why I'm using Kaggle. It's free, which is good. So it's cheaper competition wise. And then secondly, it's also faster because like this pre-trained model that we're using, right? Let's see, it's um, it's a model trained on ImageNet, and that ImageNet is basically is a 1.2 million images using 1,000 classes. So it's a multi-class classifications, right? Um, and this model, so can you imagine like training from scratch for like 1.2 million images? That's gonna take some time. Yeah. With pre-trained model, you can like make it really quick because most of the hard work is already being done. Um, and then you save you time, save money, right? So that's the idea. Um, so this pre-trained model is called ResNet 34. Yeah, ResNet 34. Um, and this model actually won the 2015 ImageNet competition, right? Okay, okay. So so here's how to train and evaluate dogs versus cat model in 3 lines of code and under 20 seconds. Okay, we'll see. Okay, so we can ignore this. So the arc we're using ResNet 34. We are making a data object basically, and inside the object is basically has a function image classifier data from names and array, and the path is path, which is basically the input path here earlier, right? The f names equals to f name. The f name is basically all of the file names, each of this. Remember, f name is an array of all the training images that we're gonna put or insert inside the neural network. In this case, a ResNet 34 model. Um, and then we put also the labels is also a bunch of array of 0 or 1. 0 is a cat, 1 is a dog. So remember, uh, in order for the machine to learn, we need to put one. We need to put basically two things, right? The data and the output or the label, right? And then of course you need to figure out what the model is, and but that's the most important thing that we have to remember: the data and the output of that. What is the data is so the machine can learn whether it's this image that the the model is looking at is it a dog or is it a cat, right? Um, oh no, what happened? I don't know what's going on. Okay, we'll do it again. Seems there's a problem. Hi, Rich. I'll bring you. Sorry, guys. That's just my daughter just came from school. She is a eighth grader. Yay. Next year is gonna be freshman. How exciting. How exciting. Okay, can I do this? Let's see if I do this. Oh, it works. It works. Okay. Okay. So we're here, right? Okay, and then task name is a task. Okay, and then TFMS. TFMS from model. Arc. Yeah, I'm not sure about this. I'm not sure about this, but this is inputting the model, the arc ResNet 34 here, and then the size is 224. Remember, we set the size here over here, 220 24 pixels. I don't know if you can change. I bet you can change it, but I do not know what does it do with regards to the learning process, whether it's going to be make it more accurate or not. We can play with it later, right? And then you set up a learn object, which is a convolutional learner, and then dot pretrain, and you put all of that the parameters inside the arc, the data, pre-compute equals true. Not sure what it is. Temporary name, temporary path is creating a temporary path for I think for the result, and then the model's name is a model path, and then learn fit 0.001. This is called one of the parameters we have to set is basically a learning rate, right? Um, Basically, the higher the learning rate is supposed to be uh, a faster, but it might you might not train the network really well. So this is kind of tricky to set up the learning rate. But later on at below, there's gonna be like algorithm how to compute that, like how to find kind of the most effective um, hello, the most effective learning rate, right? So far you just put 0.001, right? And then this is two is refers to the epoch. So epoch basically it's um, how do I say it? So when you let's say you have 1,000 images, right? In this case we have 25,000, right? Let's say you just put have 1,000, right? So if epoch 2, it means that out of this 1,000 images, you're gonna run it 2 times into the network, right? So if you put epoch 3, it's gonna run it 3 times. Why it does that? I think it has to do with um, to find a better accuracy, and this has to do with how do you understand in details. But for now, we'll set it into two. Okay, but it's just from what I think you need to know now is just to understand that two is basically the number of times the training data being like feed forward or being inserted into the network, into the model, which is ResNet 34, right? So, okay, so we'll run this. It's downloading a PyTorch model, the ResNet 34 model, right, from PyTorch. Whew. Okay, just bear with me. I think we're gonna stop here, and then we can continue the next video after after this, because it's already taking too long. I think it's already like 1 hour or something. It's yeah, almost 45 minutes. Right. And this is taking some time, right? Oh, in the meanwhile, we can wait, right? I mean, just trying to explain to you what is this learning rate is. What is like to give you like an intuition what is that. Okay, so let me see if I can explain this. So um, basically, a neural network is like it's a function, right? It's a function. So imagine if you have let's say a quadratic function, right? Like a shape of U, right? Um, so uh, choosing learning rate, and then you choose learning rate is the steps. So first, for example, um, you start from here. Probably it doesn't make sense right now, but let's say you start from here, right? Learning rate is basically how to find if you start the point from here, how do you how fast or how do you find in such a way that you make the point over here. So you um, down here at the U. So you make it like at the minimum point. Um, so okay, probably it's better if I so so let's say a neural network like this, right? This is I'm just drawing one one neuron, right? One neural network. So and if this is the data, right, right, and then this is the output. Sorry, there's a little bit of delay of 5 seconds of what I say and then what appears on the drawing board, right? Um, so a neural network is basically what you put inside here, right? And then and then and then there's a call um, a bias, and then there's a call also weight, right? So um, and the formula this neuron basically it's basically wx plus b. So this is what the neuron is, wx plus b. So whatever input, which is the x here, x is the input, the w is the weight, right? And then the b is the bias, right? And this is what basically the neuron does. It's basically computing this function, right? And then you put like a ReLU function to make it non-linear, but that's for later on. But basically, after you compute this, and this becomes the output, and then you want to the output, right? And then you compare it with the label. Let's say the label, right? With the label, right? So, or you can say the output with the prediction and with the label, right? And there is this called loss or error, right? There's this error, right? Basically, error is the output minus the label, or you can also say um, error is the y prediction. Sorry, um, the error is the y output minus the y prediction, right? The y prediction is basically from the label, right? So, and you try to minimize this, right? Try to minimize this. You want to try to minimize the error. right? Okay, so you want to try to minimize the error, right? So the error, this is what I mean by the error. This point here, right? This point could be here, right? Could be high up there, or if you're lucky, then your error could be here, right? Or you have a really, really lucky, right? Um, your error could be here, like really low, right? But normally it doesn't happen like that, right? So let's just assume the worst case, right? Then your error starts from here, right? Starts here. Starts here. So how do you go down here? How do you go down here? Because you want to minimize, right? How do you go down here? So this is where the idea of learning rate is. So the learning rate is basically the steps you have to take in order to go down. Whether you want to take like this step over here or this step here, right? Or this step here. For each of the steps that you want to take, that's the learning rate, right? Because you want to multiply it by a constant, right? So if you put the learning rate high, if learning rate really high, right? You and it's really really high. Once you go down, you can be like making like the steps could be like here, like could instead of you're minimizing, you're going up, right? You see it? So if learning rate really high, then the steps gonna be here, right? So, but if it's really really low, for example, and then it's gonna take a long time. This is gonna be probably here, this point here, right? Or probably over there, right? So you want to balance in such a way the steps is not too high or too low, right? But because if it's too high, the consequences it might not converge. You cannot get into minimal loss, right? But if it's too low, it's gonna take too long and it's gonna be expensive. Remember, this is computationally expensive and you're gonna waste time unnecessarily, right? So that's the idea of a learning rate. So we'll go back here. Okay, it turns out it's already done, the competition, computation, right? So the first epoch here, um, yeah, I'm not really sure what is this means. Like there's because there's like since there's like there's 310 and then 79. I guess this has to do with the batch, mini batch size, but I'm not sure. And that's another topic. That's gonna go really like deep dive into what's like the nitty-gritty of the deep learning. We don't want to go there yet, okay? We just want to go like keep it high level first, okay? So anyway, so the first epoch, the first iteration, uh, putting all of those, let's say if you have 1,000, in this case we have, I think 25,000, right? Am I right? 25,000, the first, all 25,000 images, boom, go through the network, the ResNet 34. And it will give you this accuracy, 99%, which is pretty good. Yeah. The second epoch, though, actually is worse, 98.9. So actually, the second epoch is the later epoch is not necessarily to be better, you know, but the chances are the more number of epoch you have, or you like uh, 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 make it available, then you have options, right? Which one to choose is the best. For this case, is the epoch zero, is the first epoch basically, instead of the second one, right? And 9895. Yeah, I think this is correspond to the last epoch, 989517. Okay, so how good is this model? So, well, as we mentioned prior to this competition, the state of the art was 80% accuracy. That was 2003. Oh wait, 2013 is it? Um, no, wait, when was that? I forgot. I think 2003. Oh, 2013. Yeah, 2013. Yeah, this one, 2013. Okay, that was about yeah, 5 years ago, right? And it's so we beat them definitely because we got this like almost 99%, right? Especially for the first epoch, the epoch zero, right? So, um, right? So we beat the result in seconds. We trained in seconds. Basically, probably it took like let's see, over here it says like 9 seconds. I don't know whether that's, I feel like that's like slower than that, but I don't know. But nevertheless, it's probably less than 5 minutes and so on, right? Because the time I tried to explain what is the learning rate, I think it just took like 5-10 minutes, right? And it's already done, right? So even last year in the same course, our initial model had 98.3 accuracy, which is nearly double the error we're getting just a year later. And that took around 10 minutes to compute. Oh, wow. Okay. Okay, so that's it for now because it's almost like 1 hour. I feel it's kind of too long. Well, the next video, I think we're just gonna try to do the continuation to analyze what's happening, yeah, the pictures, right? Okay, I'll see you next time. Stay tuned. Thanks for watching. Leave any comments below. Please ask any questions. Stupid question. There's no such thing as a stupid question, right? We are still learning, right? I'm just here like probably one step or 2 steps ahead of you, but we are all still learning. All right. Stay curious.